Hi guys, now we have the IGCSE O-level mathematics topic, functions. So a function is actually a process which converts any input value x into an output value fx. So for example, this one, a function h is in this box, which is converting all the apples into halves. So it means we can say that the function is h, the name of the function, and x is the apple, and it is converted into half of the apple x. So in detail, first of all, we will do the function notation, then we will do the value of the function, then inverse of the function, and then the composite functions. Okay, so starting with function notation. So usually two notations are used for f of x. So fx means function of x, and it is read as f of x. So when f of x is written, so it means f is the name of the function and x is the input value which we insert in that. Another way is f of x is equal to 3x plus 1. This is the example. So it can also be written in another way, which is fx tends to 3x plus 1. So both these notations are same. So when fx is equal to 3x plus 1, so x is the input and the output will be 3x plus 1. For example, if x is 1, so 3 times 1 plus 1, which will be 4. So output will be 4. Now the value of the function. So usually this kind of knowledge we need, the basic knowledge. So an example, f of x is equal to 5x squared minus 3x plus 1. So here input is x, this input here is here and here. Now see, if the question is find f of 2, so it means we will replace this x with 2. Wherever is x, we will replace it with 2 like this. So it means that f of 2 is equal to 2 into 2, 5 into 2 square minus 3 into 2 plus 1, so it is 15. Another example, if fx is equal to 5x minus 3 over 2x plus 2 plus x. So these are the x here. So f of 2 we have to find, so it means all the x's we will replace with 2. So we will get 5 into 2 minus 3 over 2 plus 2, so which will convert into 7 over 4. 5 times 2, 10, minus 3, 7, divided by 2 plus 2, 4. So when we are finding f of 2, so the answer is, output is 7 over 4. Now this is another example. Given that another function gx, so the name of the function is g, is equal to x squared minus 3. So we have to find g of minus 2. So it simply we will replace x squared with minus 2. So then it will be 1. Another example, f of x is 2x squared minus 3x. So find the following. So now we have to find these three things. First green one is f of 3, second 3 times fx, and third is f of 3x. So all these three are different things. So first f of x we will find, sorry, f of 3 we will find. So it will be, the definition of the function is 2x squared minus 3x. So replacing x with 3, So it will be f of 3 is equal to 9. Now the second one, 3 into fx means 3 times the fx, and fx is 2x squared minus 3x, so this is 2x minus 3x. So now we will multiply it inside and we will get 6x squared minus 9x. So which means that 3 into fx is 6x squared minus 9x. Now the third one, f of 3x means that x is replaced with this 3x. So here all the x this will be replaced with 3x. So we are familiar about this before. So it is this, and then it is 9x squared, and this is 3x. So the answer is 18x squared minus 9x. Okay, so these are the three parts of this example. Now another example is, let gx is equal to 5x plus 6. Find the value, find and simplify g of n plus 2, which means that this x will be replaced with n plus 2. So this one, so it means now we have to just simplify it. So when we simplify, we will get this. So it means that the final answer is 5n plus 16. Okay. Now f of x is x squared plus 1, and we have to find x, but it's given that fx minus 7 is equal to x. This is an equation. So this is an equation which we have to solve to find the value of x. Now what is fx? Fx is x squared plus 1. So we replace it with x squared plus 1. So it is x squared plus 1 minus 7 is equal to x, which is a quadratic equation. So in case of quadratic equation, we know that we bring all the terms to one side and we always put equal to 0. And then we think that how to solve it. So it is easily factorizable. So we'll factorize this. Then each of the factor will put equal to 0. And then we will get x is equal to 3 and x is equal to minus 2. So these are the two possible values of x when f of x minus 7 is equal to x. Okay, now we will go to the inverse of the function. So inverse of the function is, this is the diagrams. If we see what inverse actually means, like this is a function fx which is converting, the procedure of this is that it converts the apples into lemons. So the inverse function will be that it will convert the lemons back to apple. This is f inverse function. F inverse function will give the notation, function is f, so inverse function will be f to the power minus 1. It is just a notation, f to the power minus 1. It doesn't mean that f inverse this is equal to 1 over f. No, it's not this. It is just a notation, f minus 1. Okay, this is another example. Like this is a function which is converting the diamonds into spheres. So the inverse function will be the reverse procedure, like the spheres are converted into diamonds. So this is f inverse. Okay, now mathematically we have this question that gx is equal to 5x plus 6, and we have to find the inverse of the function g inverse x. So steps we will always follow. So here I will explain in terms of the steps. So the steps are, first step, first we replace gx with y. So this gx will be replaced with y. And then the second step is make x the subject of the formula here. So which means that we convert this 6 to the other side, and then we divide both the side by 5, and we will get x is equal to y minus 6 over 5. So actually we got the inverse function here, but since it must be in terms of x, so we will replace all the y's on the right side with x. Like only one y we have here, so this y will be replaced with x, so it will become x. So it means this is the result, that inverse function is x minus 6 over 5. So these are the steps to find the inverse of a function. First we replace x with fx or gx, the name of the function, with y, and then we make x the subject, and then finally when we have made x the subject, so we'll replace all the y's with x and we will get the result. Okay, now using this concept we will do one more example. So here this is fx is equal to 3 over x minus 5, and we are to find the inverse of this function. So let's do this one. So here fx is equal to 3 over x minus 5, so we'll write fx as y. So y is equal to 3 over x minus 5. Then if we cross multiply, so it will be y times x minus 5 is equal to 3. So now our purpose is to make x the subject. So we will take this y to the other side. So x minus 5 is equal to 3 over y, and then x will be equal to 3 over y plus 5. So now this is actually the inverse of the function. So we'll say f inverse of x is equal to, but before that we will change this y as x. So it means it will be 3 over x plus 5. So this is the result, that the inverse function is this. Okay, then we have the composite functions. So it is actually the combination of two or more than two functions. So here one example is this. So we'll do this in our next slide. So first figure we can see it, that if there is a function g which is changing apples into lemons, and there is a function f which is changing the lemon into oranges, so overall this composite function will be f of g, because g is applied first and f is applied after. So here the name of the function will be f of g. So f of g will be written as, mostly we write it as f of g of x, because on x g is applied first, so that's why here g is applied first on the fruit. So overall it is changing apple into oranges. So the composite function f of g is changing apple into oranges. So this is another example, like sphere is changed into a cube, and then f is changing cube into a diamond. So overall the sphere is changed into diamond as a composite function. So this is the composite function f of g. Remember, when it is written f of g, so g is applied first and then f is applied. Now mathematically the examples, the composite function is gf of x. Gf of x. It means f is applied first on g, and then f is applied on x, and then g is applied. So here, if we see individually, so fx is f of x is x square, and g function gx is x plus 1. So let's say that we take an input 3 to the function f first, so it will convert it as 9, because 3 square is 9, and now input is 9, and x plus 1 will make it 9 plus 1, so it will make it 10. So it means overall in this composite function g of f of x, it changes 3 to 10. So now see mathematically how we will find what is g of fx, the expression for g of fx. So g of fx will be equal to actually g of fx. What is fx? Fx is x square. Fx is x square. So we write here x square, and then what is g of something? G of something is that thing plus 1. So it means it will be then x square plus 1. So it means overall gf of x will be equal to x square plus 1. Or we can say g of fx is equal to x square plus 1. These are two different notations used for the composite function, either this or this. So now see that if we directly put here 3, because the input was 3 in the beginning, so it will be gf of 3, so that will be equal to 3 square plus 1, so that will give us 9 plus 1, which is equal to 10. So see that we got exactly the same output. Here we did in parts, here we did it directly. It means that this whole function is gf of x, and its definition is it is x square plus 1, right? Okay, so now we'll do one more example. So this is, if you see, it is not a composite function example because gx is 5x plus 6 and we are to find g of f, which means f is not a function, it's a letter f. So it means we will replace x with f. So simply we replace x with f, so it will, g of f will be 5f plus 6. Now we will do an example of the composite function. So let g of x is 5x plus 6, it's a blue function, and fx is equal to 3x plus 1, it's a red function. So we have to find the composite function f of gx. So f of gx means that this f of gx means this, that f of g of x, and g of x is the blue function, this. So this one will be replaced with its value, which is 5x plus 6. So now f of 5x plus 6 we are to find. So which means if we do it separately, so f of x is 2x plus 1. So then it means f of this x will be replaced with 5x plus 6. So it is replaced with 5x plus 6. This x is also replaced with 5x plus 6. So it means it will become 10x plus 12 plus 1, which is simplified to 10x plus 13. It means that finally f of g of x is 10x plus 13. Okay, so this is the composite function f of g of x. On the other hand, if we find f of g of f of x, like if we are to find g of fx, so it will be different than this. Now see, it is g of fx, so which means it is g of fx is 2x plus 1. So now g of 2x plus 1 means that we'll use the definition of gx, which is this. So here in this x we will replace this with 2x plus 1. So it means it will become 5 into 2x plus 1 and then plus 6. So simplifying this, it will be 10x plus 5 under 5 and then plus 6. So this is 10x plus 11. So see, it's different than this one. So that's why generally we say that f of g of x is not equal to g of f of x. In some cases they are equal, but mostly they are not equal. So generally we can say they are not equal. Okay, so then some important notes about the function. So there are only two notes we will consider here. So if we are to find the composite function f of f inverse of x, which means f inverse of x, so remember it is always equal to x, because function and its inverse cancel out each other. In the same way, f inverse of fx, which means f inverse fx, that is also equal to x. So this is equal in both ways. F of f inverse or f inverse of f, both are equal. Okay. Then another fact is that g f of g whole inverse of x is always equal to g inverse f inverse of x. So when we open the bracket for the inverse function, so we change the order of the functions. Like before it was fg, now it is gf. Like if I explain you in another example, like if it is f h inverse of x, so it means we can write it as, we'll change the order of f h as h f, and then we write the inverses, individual inverses on them. So this is another fact about this. Okay, I hope you have understood these